As seen in the experiment, we can now calculate the speed of light. But first, let's look at the structure of a wave. Waves consist of a series of peaks and valleys. The peaks are called crests, and the valleys are called troughs. One important feature of a wave is called the wavelength. One way to measure it is through the distance between the region having a crest and a trough, like this or this. Another important feature of a wave is called frequency, which is how often the crests and troughs appear over a certain period of time. To help explain frequency, take a look at these two waves. They obviously look different. The one on top is more narrow and scrunched up, while the bottom is wider and spread out. Something to notice is that this is over a period of time, 5 seconds. Over a period of 5 seconds, which wave has more peaks? That's right, the top one. So we say that the top one has a higher frequency than the bottom one. We can also say that the distance between the crests is called wavelength. So we can say that the top has a short wavelength while the bottom has a long wavelength. Now let's look at our experiment with the chocolate bar. From the diagram, we see that the two melted spots don't exactly span an entire wavelength. They actually span about half a wavelength. And in our experiment, we measured the distance between the melted spots to be about 6 centimeters. This is half a wavelength, so the full wavelength is just that multiplied by 2. Full wavelength is 12 centimeters. So we have the wavelength down. Now how about frequency? Almost every microwave in a household has the same frequency, 2,450,000,000 hertz, or cycles per second. Just for reference, this is one cycle. Now imagine 2.45 billion of these cycles per second. Now that we have wavelength and frequency, we can now calculate the speed of light. The speed of light is the wavelength multiplied by the frequency. But wait, why is that? Well, let's think about it. This picture showed us that it is one cycle. Also, remember this picture? The red dots mark the beginning and end of one cycle. So one cycle means that the wave has traveled one wavelength in that period of time. Since we have a microwave, instead of one cycle, it has 2.45 billion cycles. So we must multiply our instance of one cycle 2.45 billion times to find out how much distance the wave traveled in 1 second, which brings us back to our equation. Speed of light equals wavelength times frequency. We plug in our values and we get our speed of light to be 29,400,000,000 centimeters per second. We compare this to the actual speed of light, which is 29,900,000,000 centimeters per second. And our experimental value is pretty close to that. Light is so fast it can go around the Earth 7.5 times in 1 second. Try doing the experiment several times and make sure you are able to get around those numbers. We repeated the chocolate experiment, and our second trial was 5 centimeters distance with 10 centimeters wavelength with the same microwave frequency to get 24,500,000,000 centimeters per second. You can also try with other foods like cheese. In this case, we got 7 centimeters in between the spots with a full wavelength of 14 centimeters with the same microwave frequency to get 34,300,000,000 centimeters per second. Thanks for watching, and we will take any questions.